Okay, hey guys, I'm back. It's the same day I did the last videos. The dogs calmed down, so I decided to go ahead and do my whole cell conversation, genetic conversation with you. Again, for anybody who stumbled on this and isn't friends or family, welcome, but I'm not a doctor. I am a patient, and I'm just, I ask a lot of questions and I read a lot, and so I've got information just enough to be dangerous. So I'm going to explain what I have learned. Again, not a doctor, but maybe it'll help you ask questions or know enough to know that you have some questions, or it informs you enough to have conversations with folks about it, or I don't know, for whatever reason. So we'll start with the fact that I saw a geneticist, right? Early on, I was diagnosed. Then they sent me to a geneticist because I was young. They wanted to test my genes, asked me if they could. And I said, sure. So they don't test everybody's. But I guess I'm young for breast cancer in the scheme of things. The majority are a lot older. So I said, sure, you can test. I said also, my dad got breast cancer a month ago. And they were like, that's interesting too. He got tested because he was a male. So we both have a genetic report out there. So I go to meet with this geneticist to give me the results. She looked 12. My husband and I are sitting there. I've only just found out I had cancer not that long ago. So I'm hoping to get some information from this. And I did not. What I found out just made me salty. Very salty. Like, if I had poor manners, I would have just gotten up and left. It was a complete waste of my time. And I was mad that I was there because here's the thing, folks. The PR department for cancer has done a really good job at making us think that the majority of cancer is hereditary or genetic in some way, or like if you're a smoker, you can get it from smoking, or asbestos, you can get it from that, things we know about. So no. So I don't know if you're sitting down, but you need to sit down for this. Get a pen and paper if your memory's bad. I'll wait. Okay. Hereditary cancer makes up only 5 to 10% of cancers. Mind blown. 5 to 10%. That's it. 5 to 10%. And I was like, wait, hold on. What? Why do y'all have like 15 pages at every doctor's office that ask us about, does your mother, your father, your grandfather, your aunt, your uncle, your cousins, And I heard a comedian once, I don't remember who it was, but it was funny because it's not like you go to like your family reunion or Thanksgiving, you're like, all right, who has high blood pressure? Who had cancer? Anybody? Come on, guys. Come on. Who had any kind of cancer? Anybody? How about high cholesterol? I see you with the mac and cheese. Yes. So, I hate those things. Absolutely hate those things. And it turns out it doesn't even matter. Really? 5 to 10%? Just look at all of us. What are you doing? And she said, I go, what are the rest? And she goes, the rest, we call, the rest are sporadic. Sporadic. This really was me. I went sporadic. So random. They're just random. Like you don't know why we get them. And she's like, no, we. Mm-mm. So I'm like, I think, and my husband and I are just looking at each other like we saw the man behind the curtain. You know what I mean? Wizard of Oz, for those of you too young. I mean, wool from our eyes, whatever analogy you want to use. We just were like kind of flabbergasted, like we're going to need a minute for that to sink in, because we have been made to think it was a much bigger number. So I wasn't thinking of breast cancer because I'm thinking I don't have any genetic markers. I don't have any genetic markers that I was aware of. Like, because nobody in my family had cancer. Nobody. My grandpa had lung cancer, but he had smoked eons before, so it also didn't register as like I put that on paperwork, but he was a smoker. So I'm not thinking of any of that. I don't have anybody who has breast cancer in my family. None. Not even the ones who are married in. You know what I mean? That aren't even like blood related. Not even them. Nobody. And I don't have any markers. So my dad and I were both tested. We have no genetic markers for breast cancer. None that they have discovered. We may share a marker that just has not been discovered as a breast cancer gene yet. But at this point, we don't have it, right? And she was also like gung-ho. They were very gung-ho initially. They're just like, and if you have a marker for ovarian cancer or uterine cancer, I was like, we may take all those things out. And I was like, well, slow your roll. I just found out I had breast cancer, and you're like, we're gonna cut this off, and then we may need to cut this off and cut this out and cut this out. And I was like, everybody calm down. Calm down. Like, let's be cool. So most cancers are random. And I said, well, what about all these, factors for this and this and this? For breast cancer, they said the only things that they know for sure that cause breast cancer are if you are female and you have breasts, you're female and you're aging. And they even got that wrong because my dad's not female. The aging they got right. He's definitely aged. But he's still a handsome man. But, yeah. But if you're a woman and you're aging, you're probably going to get breast cancer at some point. 1 in 7, I think, is the number, or something like that. So it sounds like, from what I've understood from talking to people, is we have a lot of data. What we don't have is the ability to correlate it all. So you can correlate something like asbestos, because you can see it happen here, and tie it all together and say, yes, this caused cancer. But for them to correlate, like my dad and I working in the same building or the same company, or me being in the same house for X amount of years, there's no way to really correlate that unless they followed that, or they were able to study enough parent and child relationships where they didn't live together. And that is not as common. Most parent and child are living in the same space. They have to have something else to like put it against, right? So they can't correlate all the data. So what they don't have is the information. And I felt like it was a complete waste of my time. So that's your genetics in a nutshell. Now, when it comes to cells, so this is where you really need a Schoolhouse Rock. I'm just a cell, just a working on, I don't know. Somebody can come up with the lyrics, I'm sure. Somebody can do something cute. Okay, so I had a geneticist friend who told me most of this, and then between what the doctors have told me and everything else, debunked a few things. I'm going to debunk a few things. I debunked it for myself because I didn't know. My assumption was that my dad and I would have the same type of cancer, right? So we both have breast cancer. I'm waiting on the results of what type. And I'm thinking, well, I'm probably going to have the same as him, right? It's a familial thing. So the types of cancer, anybody can have any type at any point. So if my cancer comes back, it could be the other type. It is not this is the type you have in your genes and in your DNA or whatever. Every cell has the ability to do it. So it's all about cell behavior. So a cell has some kind of cascading cycle, right? And think of it like a tree trunk, like with all the rings, or better yet, think of it like a record. So you have this beautiful shiny record is a perfect cell. It's a good cell. Most cells, when our body's making cells all the time, right? Making cells, cells die all the time. And we have a way to get rid of dead cells. We have all that stuff. When cells are created that have an error in their code, their operating thing, so it's like a trunk, it's like a tree trunk where there's like all these rings of information, right? So it's like every cell, let me start by saying every cell in the body knows what type of cell it is. I mean, the human body is fascinating. This is fascinating. So every cell has wiring and coding to know that it is a heart cell, a lung cell, a liver cell, a skin cell, a breast cell. A breast cell looks very different than a kidney cell. And I know that I know I'm a breast cell. I know I'm supposed to be located here. I do this. This is my function. This is my this, right? It has all this information. If it didn't, I guess we'd all look like a Picasso, right? We'd all just be a hot mess if cells didn't know where they were supposed to be. So that makes sense, right? So glad God sorted that out. Otherwise we would look crazy. So, no, wait, no potty. So if you think about it like that, like it all has this coding, right? And it's going through its little process and its creation or whatever. So let me start by saying that the body has a process for, so sometimes cells are made and they're a bad cell. They're messed up. And the body sees them and gets rid of them. Cancer cells are cells that were messed up cells that the body did not see for whatever reason. The damage was further in, or it was masked, or whatever reason. I don't know. It was asleep on the job. Somehow, this messed up cell got through. So you can think of it, as a tree trunk, it's got a cut in it or whatever. Or think of it like a record that has a scratch, right? So that record has a scratch. Your body didn't see it. Whether or not something is, wow, there's so many things. Which one should I start with? I'm trying to make it the easiest. So I'm trying to go in order. So the record has a scratch. It's damaged. Okay. So there are several things that I will tell you. So you have a record with the scratch, right? Body didn't notice it. One of the tests they do is to tell you how aggressive your cancer is. Okay. When a cell looks different than the cells around it, so it has that scratch, it doesn't look exactly like the other cells. What happens is it looks around. It can stay dormant, right? It can be like, I'm not noticing anything. I'm just kind of asleep or whatever. I'm a little zombie cell. I'm just asleep. I'm not noticing anything. That's a non-aggressive one. It's not feeling threatened. It's not trying to do anything. It's just busted. It's just not a good cell. Okay? And, it's fine. That's non-aggressive. The aggressive kind is, it's going, okay, I'm surrounded by cells that don't look like me because it's morphed. There are levels of, I think I told you there are levels of how the cell looks. It's like, it was a breast cell, but it's got some damage. Well, it's kind of morphing. So here it is looking like a breast cell. Here it looks like a totally different type of cell. It doesn't look like anything else in your body, but it's become its own thing. And there's a spectrum along that line of how much it's completely changed to something entirely different. So mine was in the middle, right? It didn't look like a breast cell completely, but it wasn't completely, totally something else. You could see some breast cell bits, right? So that's a scale of aggressiveness. The other part is it I want to say awake, but it's like a zombie, right? And it's looking around going, what are these cells? Oh no. And it feels threatened, and it either converts them all, like a cult, right? It's like, hey, no, you could be like me. It converts them all to, these busted whatever cells, whatever it looks like. Or it flees and it tries to go set up shop somewhere. It tries to go find where it belongs, because the messaging for a cell is go be in the place you're supposed to be. If you're a skin cell, be on the skin. If you're a liver cell, you're in the liver. So its first line of thinking is, I need to be where I'm supposed to be, And so this no longer breast cell is going, well, I gotta go find where I need to be. And hence it travels through your body and sets up shop in different places. It still doesn't belong in. But, so mine, of course, was, making everybody around it become like it, creating this tumor, this large mass of cells that look like it. Whether or not it was gonna flee or did flee, it hadn't gotten far. But my dad's was already in his lymph nodes, it was outside his lymph nodes, it was traveling. So that's when it's considered aggressive, because it is feeling threatened and it's gonna cause damage, because it's gonna go seek and find another place to be. and it's gonna multiply, etc.